So last class we had covered some of the collection framework objects, and we had also seen the collection framework hierarchy. And most importantly, it's necessary to understand which collection framework uh, data structure we should use and when to apply that. So we had seen collection framework uses, like when do we use list, when do we go for a map, when do we go for a set. And we had also seen some of different data structures uses like queues, dequeues, stacks. And I had given demonstration of lists and sets in the last class as well. So it's necessary to understand, means implementing this is like quite easy. Means if you are able to like understand one of the data structure collections, so it will be like easy for you to like understand others as well, like in terms of the methods that we used, in terms of the APIs that each of this collection framework holds. So that is like quite easy, but it is very necessary to like understand which of the data structures you should use and when to use those. So we had seen this collection hierarchy diagram last class, and basically these are extending from the collection interface. So we had seen when to use sets, lists, queues. So sets basically we need to use when we don't want any duplicate elements in our collection. List we use when we want to add uh, a number of objects to the list. Queue we want to use when we want to have something of a FIFO kind. FIFO is basically first in, first out. I had given the example of person standing in a ticket queue, right? So the person who is first in the queue, who entered the queue first, so that will be the person who gets the ticket first and gets out of the queue. So these are some of the scenarios you should think before using any collection framework data structure. So, and each of these interfaces is provided an implementation by its supporting class. For example, set interface can be like implemented by classes like hash set, linked hash set, tree set. So we had seen when to use hash set and when to use linked hash set and when to use tree set. So hash set is basically used when we are not concerned with the order of the output. Suppose irrespective of the input that we provide, and we are not concerned about the order of the output, means it can provide output in the random order. And linked hash set is basically when you want to preserve the order of output. Preserving the order of output is basically like the order of the input and the order of the output is basically same. We suppose you added something to a set first and then you added something else, so that order will be maintained while you traverse and print the output as well. And tree set is basically used when you want to have the elements in sorted order. We had seen both the demos where we want to have the elements in ascending or descending order. So anyone who has missed out that can also go on the YouTube channel and see how we had seen. So the natural ordering is basically ascending order. If you want to like implement something in descending order, you can use something called reverse comparator. I had already shown that demo last class, and I like emailed those demos as well. So in case someone has not seen, kindly go through those. Then we had covered like list interface as well. So list interface is basically implemented by the array list, vector, and linked list. I've shown you the examples of array list and linked list. Vector is a legacy collection, so it's not very much used now. So I had not given the demonstration of this. So today we'll go through some of other collection framework objects, like we'll go through maps, we'll go through queues, we'll go through stacks, we'll also try to see if we can cover stacks. So let's start the session today. We had also shown you how we can basically use these iterators to iterate over different collections, and I had also shown you the difference between fail fast and fail safe. So just to recap, fail fast and fail safe is basically if you are trying to traverse through a collection and you are modifying that particular data structure, if it gives any exception in such a case, then that is a fail fast behavior. And one of the data structures which you can think of is like array list. So if you are traversing an array list and simultaneously you want to add something to the array list, you will get an exception. But you can use a different version of array list like copy on write array list, that is fail safe. So even if you are traversing that copy on write array list and you are trying to modify that, that will not provide any exception. So this is a very important question, like fail fast and fail safe. So I'd also given the demos of both of these, so kindly see that as well. So we had covered set interface as well. So set interface was like implemented by hash set, tree set, and linked hash set. Let's start with today's topic, that is map interface. So map is basically used when we want to have something of a key value pair. Suppose you want to have some key and then you want to associate some objects with that particular key. So consider a kind of a dictionary kind of thing. Suppose in a dictionary, when you have a letter A, so in that particular page you will see like all the words are starting with the letter A. So consider it like a dictionary. So in that case, let's say A is our key and all the different words in that particular page are the values. So let's consider like these are key value pairs. So whenever you have a scenario like you want to use key value pairs, then you have to basically go for a map. So this is a dictionary kind of a feature. So let's say uh, okay, let me try to create a package for this. Okay, let me try to create hash map demo. Okay, let's think of something like you have an integer, like you have some kind of like ID and you want to associate some amount to that. Suppose let's say we have some person's ID. Let's say the ID is 1 and this person has suppose received marks in different subjects, and this marks can be like 10, 12, 15, or it could be just like cumulative marks. Let's say he has received total marks. What I'm basically doing, I'm creating one person's let's say this is a student ID and this is the marks obtained. So let's say the person with roll number 1 has received 100 marks. Let's say the person with roll number 2 has received like 65 marks, and let's say the person with roll number 3 has got 50 marks. So when you want to like query something like find out uh, the ID with okay, find out the ID with maximum marks. So what you want to do in that case, you need to basically traverse through this collection, and then what you can do, you can compare, you can basically keep track of the maximum marks, and whenever you get the maximum marks, you can print that out. So this is kind of a scenario where you can basically uh, use a map. Map is kind of a dictionary where this is a key and this is the value. Like ID is the key in this case, marks is the value. So let's think of another example. Let's modify this example itself. Let's say I have the ID of the student and I want to store marks in different subjects. Different subjects. So what I can basically do, let me just try to copy this. Okay, one second. Let's say in one of the subjects, the student has the person with roll number 1 has got 100 marks. In other subject, he got 95 marks, and in the third subject, he got 80 marks. Let's say the student with roll number 2 has got 65 marks, and then 50 marks, and then 75 marks. Similarly, let's say this person has got 50 marks, 95 marks, and then 45 marks. So I want to query such a way that I want to get all the, let's say I want to fetch the person with ID 2. I want to get like all the different subject marks. So what I want to basically do, I want to query the ID with person, the person with ID 2. So basically I want the details of this particular person. If I want to say like what is the average marks of this particular student with roll number 2. So what I can do, I can do a sum of these three numbers and then divide by the number of subjects. So basically this will be the ID and this will be the set of values. So it's like this. So map contains key value pairs and this key value pairs can be like any objects as well. So like you can have integer mapped to integer, you can have integer mapped to a list, you can have a ID and then map to students details. So you can like have different kind of combinations, and you can like query with the help of the ID. Let's say you want to get all the details of a person with any particular ID, you can get that. So we'll go through the implementation and see when how we can like implement this. So these are some of the scenarios. So anyone has any questions on the usage of map with scenario? Basically, did you understand the scenario? That is like more important. Implementation is like very easy, so it won't be that tough, but understanding the scenario, that is like more important. Okay, let me go through one of the examples. Let's say we have an ID and then we have total marks, and let's say I have also like, okay, we can also utilize different collections. Like last class we had already seen how we can use a list and a set. So let me try to use a list as well in this case, and that list will basically contain marks of different subjects. So I will create a list of integer and I will name this as subject marks. and let me try to create a constructor for this. And we will also try to generate the getters and get the getters for this. So you are already aware about how to generate these getters and constructors through the editor, right? So let's say we will now create some objects of this hash map demo. Okay, let's term this class as, let's rename this class as student, and I'll just write on top hash map demo as documentation, so you can like understand whenever you go through this class that this is a hash map demo. Okay, let me try to create a student object now. Student s1 is equal to new student, and I'll pass the id. Let's say I pass, okay, we have like list of arrays dot as list. Let's say the student has got 100, 50 and 50 marks, and the total marks is 200. Now let's say we create another student object. The id associated or the key is like 2. Let's say I want to like create something like, okay, this is 2 arrays dot as list, and let's say this has marks as 100, 50, 30, and overall it would be 180 marks. Student s3 new student 3, let's say the id is 3 in this case, and the student has got marks like 50 comma 50 comma 40, and the total marks is 140. So now we have like 3 student objects with their IDs, marks in each subject, and the total marks. Now let's see how we can like utilize our map to create a mapping for this. Let's say I want to basically create a map, and I want to map the ID, and I want to map uh, the total marks. Let's say I want to map the total marks. So what I will do, I will create one map, hash map. Let's name it like HM, and new hash map. So the key and value would be basically, key would be ID, and value would be, let's say, total marks. So what I will basically do now is I would, so this map has basically an entry object. We'll see. So you can use this particular method, put method, to provide the keys and values. So the first argument that we basically provide here would be the key, and the second would be the value. So let's say I want to provide the first key as the ID. So what we can do, s1 dot get ID and s1 dot get total marks. So this is the mapping that we want, right? We want the mapping between this ID, student ID, and the total marks. So the first argument is basically the key. I can do a s1 dot get ID so that I can have the ID of the student as the key and the total marks as the value. So this is the mapping, ID and total marks. Similarly, I will create the entries of other students here. S1 s2 dot get ID, s2 dot get total marks. Let's say sm dot hm dot put s3 dot get ID, s3 dot get total marks. Now what we want to do, I want to basically print all the student details. I want to like print which student ID has how much total marks. So for that purpose I need to basically print out the print out the uh, values and keys. So what I can do, if you want, if you already know the ID, so let's say you already know the ID. So student with ID, let's say I want the details of student with ID s1 dot get ID has secured s1 dot get total marks. So I want to like print out the student. Okay, I would so I would use the map. Let's say, sorry, hm dot get s1 dot get ID has secured. Now my map has the total information, right? So I would use something like h1 dot get s1 dot get ID. See, in this particular map, uh, what entries I've made, this ID is the key and this total marks is the value. So if I want to get from this map, like if I know the ID, so I can get the mapped marks of that particular person. So what I need to basically do, I want to use this get method. This put method was basically hm.put. Put method was basically to create entries in the map, and this get method is basically to get the details from the map. So what I can do, I can do this get operation on the map, hm dot get s1 dot get ID. So let me try to run this. See, student with ID 1 has secured, student with ID 1 has secured 200 marks. So we are able to get the total marks of the particular student. So what basically I'm doing, I'm querying with the person's ID. I am querying with the person's ID, and ID is basically the key. So let's say if I want to print out the details of of all the persons, I don't want to like do it one by one. So in this map, there is one library called as entry object. So there is a method map dot entry. So if I'm just writing out this map dot entry, so you can see the suggestions that it is providing. In the brackets, it is providing k comma v. So k comma v is basically k stands for key, v stands for value. So when I write down this map dot entry, so I will need to use angular braces, and in this angular braces I need to provide the type of the key and value. So when we created our map, our key and values we defined as integers and integers, right? So in this case, what we'll basically do, we have to traverse this. So we will provide the same entries like integer comma integer, and we will provide some value, some variable like entry. So you understand this is the same for each loop, right? We had used this for each loop for traversing. So this is the type of data object, each entry that I will be receiving, and from where I will receive this. So this hash map has one entry set method. This is one entry set method. So this is how you can basically traverse a map. This is also an important question. Sometimes the interviewer might ask you to like create one map, populate some objects in that, and then they might ask you like how would you basically traverse through this map collection. So I would just write down some documentation, traverse through the map. So what you can do, this is our for each loop. You remember this syntax, right? For something like integer I, we used to do something like this, right? And suppose we had some kind of list or arrays. So we used to do something like this, and then we want to print out. So this is also similar. This is also similar. This is a for each loop itself. So I have like for, and then here the expected data that we are receiving each time is an entry object. This is called entry object, and we populate this by map.entry and then provide the key and value data types, and we can use some reference variable like entry and this hm.entry set. And then what I will basically do, I will create some value like integer id. So from this entry set, what I can do, entry dot get key. So our key was student id, right? So I'll be getting the student id, and this is like total marks. Entry dot get value. So let's print this out. S1 dot get id, get S1 dot get total marks. So let me try to print this out. id, okay, okay, sorry, not s1 dot get id, sorry. This is like, oh, I want to print out the id here. We had already populated the id, and I've also populated the total marks. Id is equal to id and total marks. Let me try to run this. So id 1, total marks 200. ID 2, total marks 180. ID 3, total marks equal to 140. So this is how you can create a map and traverse through the map. Now let's say you had another requirement. Let's say you have another requirement where you want to basically print out all the details of the entry objects. So what you would do basically in that case, you can like create a map some such as, let's say, print out all details of students. So print out all details of students. So in that case, what you will basically do, you can create a map and you can create an integer. Let's say with this person's ID, you are mapping the entire student object itself. You can also create something like this student map, new hash map, and you can populate something like student dot map. So dot put, and with the help of this put method, what we can do, let's say s1 dot get id and s1 student map dot put s2 dot get id and s2 student map dot put s3 dot get id and s3. Now print out all details of students. Let's say I want to print out the details of student 1. So s1 dot what I can do is s1 dot get id, and our map contains all the details, right? So what I can do, student map dot get s1 dot get id. Okay, one second. Okay, one second. So I want to print out something like student id s1 dot get id, and I want to print out all the details. So what I can do is from the student map I can pass the id student dot student map dot get s1 dot get id. Let's try to run this. Okay, this details is now giving me this because this is an object received. Why? Because this is an object received. And what I can do, details, let's say from this student object I want some details now. Let's say you can like fetch anything, like you can fetch get total marks. Let's say you can fetch get subject marks, and then you can also, let's say we will try to print out this now. So see, we are able to fetch student with id1 details, or you can say subject marks, and then you can also try to print out total marks. So total marks would be basically student map student map dot get s1 dot get id, and what you can basically do dot get total marks, total marks. So you've seen this, right? Are you able to follow this or not? So this time our agenda was like we wanted to print out all the details of students. So what we can basically map, how we can basically map now is we can create a map. This integer represents the roll number of the student, and the student object basically contains all the details of the student. Like this student object basically contains the id of the student or the roll number, the different marks in each of the subjects, and the total cumulative marks. So I have created a map, student map, and in the map what I've done is like I have like created an entry of the id, and then I passed the student map itself. I passed the student object itself, and similarly I have like passed the key and value pairs for the second student, s2 dot get id, and the student uh, object reference. Similarly, we have done it for the third student. So now I want to print out the details of the first student. So what I can do is student ID. So I know that the student with s1 dot get id. If we do this s1 dot get id, we can get the id of student 1. And now I want to like print the subject marks. So we'll print it out from this student map. We have already populated the student map with the details of the student. So subject marks would be basically student map dot get. This is the get method, and in the get method what we basically want to pass. So in this get method we want to basically pass s1 dot get id. If we only do this much, what we got the student object, whatever was the value student object we got, and from the student object we can do this getter method dot get subject marks. So in that case we can get the subject marks. Similarly you can like print out the total marks of the student as well. So this time what I've done, from this student map I'm using this get method, and when I do this get and pass the key, so this is basically the key s1 dot get id. When I do this I'm getting the student object reference, whatever was the value. Only through this student map dot get s1 dot get id, this will give me the value. But from the value what I want, from that particular value I want the total marks of the student. So what I would do, I would do a dot get total marks. So in this case I will be able to print out the details of the student. So I'll be able to print out student ID like one, subject marks, whatever was the different marks. So see, this is a list of marks. We had created a list in the student object, right, student class, which contains the subject marks, different subject marks, and this was like total marks. So we are able to print out all the details. So see, the query of our pattern is we can query with the help of key. Like I can query with the help of key, and when you want to like print out the details of all the students, so what you can do, you can use this for each loop to traverse through the map. So basically you need to create the entry object of the student and entry object of the map, and like get the id id you can get through this method, entry dot get key, and value you can get is entry dot get value. And the value obtained will be, if you want to get the key, it will be of integer type, and if you want to like get the value, it will also be integer type, because that is how our map was created. When we created our map, we decided that the key and value pairs would be basically of data type integer and integer. That is dependent on you, what kind of data type you want to store as key and what type of data type you want to store as a value. So this hash map concept, this map is like very important, because like you can get a lot of real world scenarios. Like suppose in your real time project you have something, says employee details. Let's say you want to like store the details of 10 employees, and suppose you have some employee id, and with that employee id you want to like associate certain details, like you can store employee age, employee address, and employee salary, employee let's say uh, you also have something like employee manager name. So these are the details that the employee has, and you want to basically suppose say you query with the employee id. So is you have like details of like 10 employees, similar details like employee id and employee name, employee address, employee's manager name, and the employee salary. Similar details you have like for 10 employees. So you created a map where the key would be basically the employee id, and then what you can do, you can like create one employee class where you can like create different data members like id, uh, id name, manager name, total uh, manager name, then whatever is the salary, and then address. So you can have different data members in that particular class. And what you can do, you can populate your map. The key would be basically the employee id, and the value would be the employee object reference. So like here we had done in this particular second example, right? Here what I've done is I've mapped the integer, this is basically the id or roll number, and the student, this is of student type. So I am passing the object reference itself here, and this way you are basically storing all the details of the student. And similarly you can do it for employee, you can do it for any different custom object as well. So this is the basic benefit that map provides. So that is why this map concept is very important, but it is also very easy. It's like a key value pair. If you know how to implement a map, you can like solve many different algorithmic problems as well. A lot of the data structure problems and some interview questions would also be based on map. So if you think of something like, they might give you some information related to a particular person. So what you can do, you can create some mapping between them, and the mapping can be like key value pairs. And when you think of anything like key value pairs, you think of a map. Whenever you think that I need to map something, some key value uh, type of data I have, then you can think of map. So this was HashMap demo. Anyone has any queries in this? Okay.
Prita,
Yes.
yeah, if you have a different data type, so can we add by separate comma?
If you have a different data type, let's say
Yeah, different data type. For example, this is integer, so when if we add string, so
yeah, you can add a string as well here. You can add a string as well here. That is allowed. That is allowed. Means you started getting error because I was passing an integer value here, right? You can pass any data type here. You can even pass a student as well, like student and student as well. You can pass a string as well. You can pass a double value as well. Anything is possible. But I had taken the example like I want to store the ID of the student, and in my example I have kept the ID as integer. So that is why basically I have kept this. This integer was basically representing the student ID, but you are free to use anything. You can use a string, you can use a double or anything here. That is like allowed. But this map will take only two arguments. Like whatever data types you have, this is for the key, this is the first argument, and this is for the second argument. And the first argument basically represents your key, and the second argument basically represents your value. But you are free to use string, double, float, anything, or any custom object as well. That is up to you. And based upon your requirement, you can choose to use any of these. So these are the concepts related to a hash map. You understood now, guess so?
Yes, Steve.
Okay, yeah. So we'll go through other things as well. Let's go through different map collection now, and we'll see linked hash map. So linked hash map is again similar to like linked hash set. So this linked hash map demo. So this would be again straightforward. Like when you have understood hash map, it's like easy for you to understand linked hash map. So linked hash map is also means it is also a type of map, but what is like preserved here is basically the order of insertion. Means here, suppose you want to like print out the student details, right? As of now I have got the details in this manner like id1, id2, id3. Sometimes if you run it for a lot of times, right, the order could be different. The first second student detail might come on first. So this is like whenever you want some kind, means whenever you want some randomness or you are not concerned about the order of the output, then you can go for a hash map. And if order of your output is not important to you, then you can use hash map. And hash map basically is like quite efficient in speed, means the performance of hash map is good. But sometimes you want to print the details in a order, like whatever order you have used to populate the objects, the similar order you want in the output as well. So in that case you want to go for a linked hash map. Okay. Okay, yeah, TJ, let me try to explain this as well. So TJ, you were not okay. Arrays.slist. Okay, so we had seen how we basically uh, populate a list, right? So I had shown you this in the previous class as well when we were going through list example. One thing is you can create a list of integer like this. Let's say list and new array list. And what you do is list dot add one, list dot add two. So you can do this way, right? You are aware of this, TJ, like list dot add one, list dot add two. So this is a list of integers, and we can add as many number of integers that we want. So now we have something like a shortcut for this. Let's say I create another list and I know that I have an integer list. Let's say I want list 2. So here what I want to do, this is a method. When we do an arrays.slist, it will create an array list itself. So that is a shortcut of this arrays dot as list. So this creates a list, and I can pass the number of integers. Let's say arrays dot as list 1 comma 2. So this I don't have to basically write these two statements now. List dot add 1, list dot add 2. Let's say I want to again add here something, right? List dot add 3. What here I want, I can do, I can just add something like this. So in this declaration itself, I am able to populate this list itself. So this is a, so there is in this Java library, basically we have arrays dot as list. So in this is also there in the util package itself, like java dot util package. If you, okay, here we have like import java dot util dot star. So when I do this java dot util dot star, means all the classes and all the libraries in this util package are basically imported. So this is also, if I do hover over it, so you can see java dot util, right? So this is from the util package itself. So either you do this or you do this. These are like similar. So this is like a standard way of like, so as in how you go on like coding, means when you will be like more into coding, you will go for this approach only, because this is like more concise. You don't want to like add a lot of like objects in this manner, so you can try to utilize this. So these are similar. You understood this, TJ, now? Okay, yeah, sure. So we'll go for a linked hash map demo. So linked hash map demo is basically when you want to preserve the order of the output. So let's say I want to create a map and I want to output the, I want to like create the same order each time I print out. So let's say I am creating an integer, and in this hash map I want to put some objects, 1 comma 100. So 1 is basically your key, 100 is the value, hm dot put 2 comma 200, hm dot put 3 comma 300. So what this does is, when I want to traverse this, again I would use that for each loop. Again I would use that for each loop. I would use that entry object, and this would again contain my key and value data types, entry, and what I would do, hm dot entry set, and I would print out hm dot, sorry, entry dot get key, hm dot, sorry, entry dot get value, entry dot get value. Let me try to print this now. See, the order of output is like 100, 1 and 100. So I'm printing out the key and value pairs. 1 is associated with 100, 2 is associated with 200, and 3 is associated with 300. So this order will always be preserved. This is guaranteed that it will be preserved in this manner only. But if we like implemented this map through a hash map, So what can happen? The order of this output can change. This can like means second object, second a detail might be printed first, or the third might be printed, because hash map has randomness. But linked hash map maintains the maintains the order of insertion. So whatever key was inserted first will be like printed out first. So suppose you inserted id1 first, then id2, and id3. Suppose you inserted key 1, key 2, and key 3. So in that same order, this will be printed. So hash map, a linked hash map basically preserves the order of output. Linked hash map preserves the order of output with respect to key. So this is about linked hash map. And whatever methods you had, like hm map dot get, map dot put, so basically all those methods will be there in this linked hash map as well. So you can try to do that hm dot, and then you can see, like we have put method, entry set, this is empty is here as well. So if you don't have any entries in the map, suppose you have just created a map and you want to see is empty, so you can, if you do an is empty, so it will basically check if there are any entries in the map. If there are no entries, then this will return you true, otherwise this will return a false. Now there are like other methods, like this clear method. Like if you want to like remove everything from the hash map, you can go for clear. You can like remove one object. Like if you want to remove an object, let's say I want to remove this one, so you can basically pass the key. If you want to, if you want to remove the uh, this if you want to remove the entry with the key 1, so you can do hm dot remove. Now if you want to print this, you will get the details of only the first only the second and third objects. Okay, let me try to comment this out now. Okay, let me try to run this now. See, after removing the first entry, what I did, hm dot remove, and you need to pass the key over here. So you can do something like this. This remove method is in this hash map as well, it is in this linked hash map, and it is in the tree map as well, which we'll see. So you can do something like this, and you can again print out that. So this is also possible. What I can do, I can write something like after removal of key. So you can try to like go in this, whenever you do this hm dot, you will get like whatever the different methods are there. There are like methods to replace as well. You can do a map dot size as well. When you do a map dot size, you will get to know how many entries are there. Then there are like different like contains key. So if you want to check whether this map contains a particular key, then you can go for a contains key method. If you want to do like hm dot contains key 1, so you have already removed this, right? So when you do this now, hm dot contains key, this will give you a false. Why? Because you have already removed this one. Now if you do something like hm dot contains key, let's say I want to do a for 2, so it will check in the map if we have this key or not. So this will give me a true. because our map still contains these two values, right? 2 and 3. So this is allowed. So you can, again, the best way to like go through all the methods is, again, you can click on this linked hash map, means whenever you hover over it and click on this, you can go in this particular documentation, Java documentation. You can see like contains value. This is the best documentation that I would say. This is the best way to learn about the libraries. So see, contains value, returns true if this maps one or more keys to the specified value. And value, what is value? Value whose presence in this map is to be tested. So similarly, see what this is like the documentation, like what get method does. You can read out this documentation, returns the value to which the specified key is mapped, or null if this map contains no mapping for the key. So when Java was like introduced, so they have provided documentation for everything. So whenever you create any object of that particular Java uh, class, and you want to go into that particular documentation, so you can basically click on that, you can go into the documentation, and you can like see whatever the different associated methods are there with that particular class. So this is one of the best methods to study. See that entry set method which I was showing you, right, the usage. So this is the detailed documentation of that. You can like try to use this, or you can like, if you don't understand something still from here, then you can like Google it. But this is one of the best methods how you can go for a documentation read. So reading the documentation is like very much important. That helps you to like know a lot. So this was about linked hash map demo. And so similarly, we have like one more implementation like tree map. So it is important to know why we use a tree map demo. So last class we had seen when you want to have something in the sorted order. So at that time you want to use a tree. So, and what tree map demo, here we will see like tree map prints out the natural order of IDs. Like this is, in short we can say, ascending order of the IDs. Now let's say I have created ID. Let's say key is basically student ID, and let's say value is marks. So when I say this, let's say we have total marks, and what I would do, so these are both integer values, right? Key would be an integer value, and this total marks would also be a integer value. So let me try to first store this, and I will use two integer data types here, integer comma integer. Let's say tree map, and I would insert, again I would use that put method to populate the objects. Let's say I'm giving roll number 3 here and 300 marks, and now what I'm doing a 3 id, let's say 5, let's say id 1 comma 320 marks, tree map dot put id 2 with 500 marks, tree map dot put and tree map dot put id 5, let's say has 900 marks. I'm just giving some random marks over here. So now what I want to do is I want to populate this. So see this for map dot entry. Again, I would use the same way, integer, comma, integer, and I would use that entry and tree map dot entry set. Now what I would do, I would get the id, id is equal to entry dot get key and integer marks would be entry dot get value. So let's try to print this out. id, okay, let's say id and this is the value. Let me try to print this out. So did you see the difference here? We are able to print this in a sorted order of the keys. See, the first object that I populated in this tree map was tree map dot put 3 comma 300 and then 1 comma 320. So I was like inserting the keys and values in a random manner, means 3 first, then id 1 followed by id 2 followed by id 4 and followed by id 5. But when I print this out, see, this is the ids are sorted and the corresponding marks you are getting, the marks you will get for this only, like the this will be now sorted based on the ids. So whatever id you have, like 1 2 3 4 5, so the first id, like us the least id will be printed out first and then followed by the next one and then followed by the next one. So basically it sorts your collection in ascending order based on the IDs. So this is like important to understand. Suppose you are given an attendance register and randomly all the students have filled their entries. Now you want to like print out the details in a ascending manner, ascending order. So you can go for a tree map in that particular case. You can print out all the details through this tree map. So this helps you in that situation. And whatever methods like this hash map has, linked hash map has, tree map will also have. So tree map, the usage is basically to sort out your data based on the IDs in ascending order. So that is why you would go for a tree map in that case. So this is important to understand, like when you would basically go for a tree map. So we had covered maps. Now we'll go for other data structures. We'll see some more data structures. Let's go for a stack. So I have told you like stack, what is the usage of stack, right? So consider, uh, let me just try to create a package, and by stack I mean that it will follow the LIFO pattern, and by LIFO pattern I mean that basically whatever uh, whatever goes into that data structure last will be the first one to be removed. So by stack I mean that stack of books or a stack of plates. So you go in a buffet, what you basically do, you pick up the plate from the top, but think of it how it was placed, means the first plate is kept on the table, and then followed by the second plate, and then third a plate from the top. So but you pick up the third plate first, right? Means whatever plate is like placed on top, that will be the first to be removed. Means the plate which is like placed last on the table is the first to be removed. So that is why we call this as a LIFO structure. So sometimes you may get some algorithmic question in your interviews, like which will basically use your stack uh, implementation. So let's go for a, we'll see the uh, methods and demo of this stack. I'll create one main method here. So let me try to take an example, like I want to store different denominations of coin, different denominations of coin. Let's say you have something like 1 rupee, $1 coin, $2 coin, $5 coin, and then $10 coin. So you have a stack now, and you have, so you want to basically store this in the stack. So let's see this. You know that these are basically integer values. So I would go for, you can create a stack like this. I would write out some documentation here. Stack is basically, stack follows LIFO pattern. LIFO is basically last in, first out. So let's say I want to, so this stack has a push method. In map, in map you had a put method. In stack you will be basically using a push method. Let's say I want to push the denomination 1 first, and then I want to basically push the denomination 2, and then I want to basically push denomination 3, and then stack dot push, sorry it was 5, right? 5, and then denomination 10. Now push method is basically helping you to enter one entry in a stack. So push method helps to insert an element. Now there is another method like pop method. Pop method will basically help to remove the element from the top of stack, from the top of stack. Let's see this example. Okay, let's go and try to print this first. Let's try to print this first. We have seen that we can like Okay, we had seen that we can use this iterator to iterate over different collections. So dot hex next. Let me try to print this out. See, this is like normal printing. So we had pushed these things and we are able to print this out. Okay, so we'll see how we can basically, okay, let's not do this. Let's use the pop method here. We'll see how basically pop method will work. Okay, so let's try to remove one element from the stack. Let's do stack dot pop. So when you do a stack dot pop, so which element was inserted first? 1 was inserted first, then 2 was inserted, then 5 was inserted, and then 10 was inserted. But when you do a stack dot pop, what do you expect? Which element will be the first to be removed? Any guesses? Pop method helps to remove the element from the top of stack. When you create a stack, one is at the bottom now, right? This is the bottom and this is the top. In between are 2 and 5. When you first made an entry, it went to the bottom and then 2 this element on top of 1, this element on top of 2 and this element on top of 5. So when you do a stack dot pop and try to print that out, you will be able to print out 10. Let's go for this. See, you are able to print out 10. Now again, if you want to do a stack dot pop, 10 is already removed. 10 is already removed. So next time if you try to print, you will be able to print 5. 10 followed by 5. Again if you do something like, so it would be 10, 5, 2 and 1. And again if you do something like pop, you will get some exceptions. See, exception in threadman, empty stack exception. Empty stack exception means you have already removed all the elements, right? 10 has been removed, then for, see, when 10 was removed, then 5 became the top. When 5 was removed, 2 became the top element. And when 2 was removed, 1 became the top element. So this is the order of removal. Whatever was inserted first will be the last to be removed, and whatever was inserted at the last will be the first element to be removed. Now there are like some more methods here which are like important. Let's see those methods as well. There is one peek method. Suppose you want to, peek method helps to fetch the top element. So if you want to basically do, just see which element is on the top, then you can go for this peek method. It will not remove that particular element from the top, but it will just fetch you that particular value. So okay, uh, see, I'm able to fetch the top element from the stack. So this can help you to fetch the top element from the stack. So these are some of the important methods from stack data structure. Okay, you have already removed this. Top element. Top element is 10, and you can do a stack dot pop till remove some elements. Similarly, you can go and see you have like is empty will again tell let you know whether your stack is empty or not. So if you have removed all the elements, this stack dot is empty will print you true. Let's print this out. So now we are expecting a true value because we have removed all the four elements. So this stack has again a lot of methods, like, but these are the important methods like push, peek, pop, is empty. So these are like the important methods. And again this is like another contains method, contains all. These are basically to check if your stack is containing this particular element. So these are like some more elements. Then you have some more methods like remove all elements. Suppose you want to like remove all the elements, you can go for this as well. But in interview questions, mainly they would ask you these three important functionalities. They might ask you the push method functionality, peek method, pop. So any algorithmic question mostly would be based upon these three methods, these four methods is empty also. So they might ask you different scenario type questions, like you are given some data and you have to print it out, like whatever was the last element to be inserted, you want to print it out first. And so what data collection or data structure you would think of in that thing? Whenever there is such a scenario, you think of this LIFO. LIFO means last in first out, and in that case you would basically go for a stack. So this is the importance of stack data structure. Anyone has any questions? This is a very easy example. Stack is a simple data structure. Are you able to understand? If you have any questions, let me know. Okay. So we'll go for other data structure. So Q is like similar. Q is just opposite to stack. So when I told about stack, I talked about LIFO. LIFO means last in first out, and I've already like given you the example of Q data structure as well, right? So Q is basically whichever element is there in the queue first will be the first to be removed. Because imagine the ticket counter scenario, right? The person who entered the queue first will be the first to collect the ticket from the counter and then move out from that particular counter. So consider that particular scenario. So whenever you have some scenario like that, like first in first out scenario, so you can go for a queue data structure. So let's write down some documentation here. Queue follows FIFO pattern. First in, first out. So let me try to create another. Let's say I want to create a queue, and this queue is basically implemented by the linked list. When we saw that hierarchy, right? When we went to when we saw that collection hierarchy, basically I had shown you how queue is implemented. If you see this diagram, see queue is basically implemented by linked list. It is also implemented by priority queue, and we'll see this queue. Let's go for a queue implementation by linked list now. We'll see how linked list can help us to uh, how linked list can basically help to create a queue. So let's go for a queue dot add queue dot add. So when we do something like queue dot add, it is similar to a push method. In a stack, you basically do a push method. In a queue, you would basically do an add. Let's say I'm doing something like queue dot add one, queue dot add two, queue dot add three, queue dot three, four, let's say five. We are adding like five elements in the queue, and we have some methods like queue dot peak. Peak will again like give you the element at the last. So when I do something like q dot peak, I'll be able to print the first element. So this will give you the first element. But this will not remove your first element. So when you do this q dot pick, this will just print out the first element, but this will not remove the first element. Now we have some method like poll method. Poll method. This removes the element. Let me try to do something like q dot poll, q dot poll. So when I do something like q dot poll and try to run now, see what I have removed from this. I have removed out the first element, because you understand the scenario, right? This is again that ticket counter scenario. The first person is removed. First person was added first. Front of queue, we can write something like front of queue, rear end of queue. So if you again do something like q dot poll, so it will be printed 2. So see, from this queue data structure, 1 and 2 are removed. So if I again do q dot pick, anyone try to let me know like which is the element that will be printed now. If I do a q dot peak, which element is supposed to be printed now? Any guesses? Yes, right. That's right, Gaso. It will be 3. Let's try to print out that. See, first element 3. Why? Because 1 and 2 have already been removed from the queue. So now if you do a q dot pick, you'll be basically get a 3 in this case. So these are the important methods in queue, like this add peak. Peak will give you the first element in, but this will not remove. Poll will basically remove the first element, and add will basically add one element at the end. So if you ever add an element, so that element is basically added at the end of the queue. So similarly you can try to explore other methods as well. If you do a queue dot, then you can basically see these methods like queue dot poll, queue dot add. We had already seen this add peak poll element of element is another method. You can try to like explore this. Just try to like print out. You'll get to understand like what is the functionality of this. Let's try to print this out. See, this will also print the first element, means whatever is at the front. So you can try to like print this out, and You can also like go for the documentation. Again, if you like click on this queue, you can basically go for the documentation, and you can like read about this, whatever methods are defined in this elements they are not get removed. Okay, Admasu, like which element, if you do a poll, right, if you do a poll from that queue, then element gets removed. If you do a queue dot pick, see, when we first created a queue, this queue was in empty state, then I added one, so this is in the front of the queue. Next, when I added two, one is at the front followed by 2. Consider that ticket counter scenario. Again I added 3. 3 is after 2. 4, when I added 4, then 4 is after 3. When I added 5, 5 is after 4. So this was the scenario. Now what I want to basically do, I want to get the first element. So you can do a q dot peak. When you do a q dot poll, right, it basically removes this element. So when I first removed, this one was removed. When I do again q dot poll, this removes the next element 2. Now if I again print out this first element q dot peak, right, we were able to get 3. So 3 is now at the first element. This q dot element is also basically like printing you the element. It will not remove. Now let me try to again print this. So see, first element 3. So peak and this method q dot element and q dot peak, these two methods are basically similar. These have similar functionalities. They will just fetch you the front element from the queue, but they will not delete that particular element or remove that particular element from the queue. So you need to understand when to like apply stack, when to apply queue. Real life example, basically when you get any algorithmic question, you need to like basically understand when you can apply queue, when you can apply stack. That is like more important. Then there are like inbuilt methods here, so this can help you to basically create that particular scenario, but understanding the problem is the most important thing. So we'll see one more uh, data structure, and that is dq, that is similar to this, that is very much similar to this, but it is having some more functionalities. dq is basically adding some functionalities to your queue. Like in queue you are basically only able to add at the rear end, means whatever comes in, you are able to add it at the rear end of the queue. But dq is like doubly ended queue. dq is doubly ended queue, means insertion and removal of elements can happen both at the front and end. So this is the application of doubly ended queue. Whenever you want something like this doubly ended queue, so there are like advanced data structure questions like trees and all, which is like beyond the scope of this, but you can think of something like this. If you want to remove something and add as well in the front, so you can basically you can add at any side. You can add at the front, you can add at the back. So dq allows you that functionalities, and also insertion and means removal also can be from the both ends. And dq is the interface. Suppose I want to like create an dq of integers, the implementation class is basically your array dq. So let me show this slide again. So dequeue was implemented by this arrayDequeue class. This is arrayDequeue. So let me try to show you the demo now. We would create this arrayDequeue, and then let's go and see these methods. See, we have add, and then we have add first, we have add last. So let's see, we would add something like add first, again dequeue dot add first. Let's say we have added two elements only. So now what I want to do is dequeue dot peak. Let and you have like methods to get first element, you have methods to get last element as well. So if I do a dequeue.pick, then it will give me 2. Why? Because when I did a dequeue.add first, 1 was at the front. When I again did dequeue.add first, then this 2 came at the first. Right? Now 2 is at the front. And when I do a dequeue.pick, right, this gives me the front element. Front element. So you can use another method like system.out.print dequeue.getLast. Let's try to see what this method does. So this will basically give you 1. This dequeue.getLast is basically used for fetching the last elements, fetching the last element. So this is the importance of this dequeue. Basically you can add at any end. Let's try to add now other element. We will try to add other element. Dequeue dot add last. So dequeue dot add last. So can you tell me like what would be the order? Which element is now at the front? Let me try to do a dequeue dot peak. So let me try to print this out. So dequeue dot peak would be 2, and this 3 is added at the last. So if I do a dequeue dot get last, this will give me 3. See, I'm able to print 3. Similarly, you have like methods to remove. You have methods to remove as well. So let's try to remove the first element. So when I try to remove the first element, what will I get? This pole first, this removes element from the front. So if I do a dequeue dot poll first and then I try to like print this out, so what happens? 2 2 will be removed from our queue, right? Because 2 was at the front. When I added 1, 1 was at the front. When I again added 2 at the front, so 2 came at the front of the queue. And I have added 3 at the end. So 2 is basically at the front. So when I do a dequeue.poll first, 2 is now removed. So now I will get 1. Let's try to see front. If I do front, then it would give me 1. Why? Because 2 is already removed by this method, by this dequeue.poll first. So see, this poll method was there in queue as well. There is a slight variation when we are using dequeue, and while using a dequeue, this poll first method is there. So you have poll first, you have poll last for removing elements from the front and back. And similarly, you have methods like add first, add last. Add first is for adding to the front of the queue, add last is for adding at the end of the queue. Then you have some methods like, again, there is an method to check if our DQ is empty. Again, there is like method, if you just do a add right, if you just do a DQ dot add, it will add at the rear end of the queue. It will add at the rear end of the queue. Then you can like print out the size of the queue, DQ basically. So you can choose to print out the size of the DQ as well. See, after removal of one of the elements, we removed one of the elements by using this poll method, right? Poll first. So now the size of the DQ is just 2. We had removed one of the elements. So now only 5 elements are remaining. So this is about DQ. This is like doubly ended queue. You can perform operations at both the ends, the first end as well and the rear end as well. So this is the importance of DQ. It is an extension of the it is an extension of basically your queue queue data structure. It extends the queue interface. We'll go for one more collection utility demo now. That's a small thing, but there are like some utility packages in collections, and that help you to basically do a lot of things. We'll see some of the demos. These are not in the slide, so you can choose to see this demo. Let's say let's say I create a list, and now you are aware about this shortcut method of populating a list, right? Let's say I create a list of integers, and I create with a syntax like this: arrays dot as list 1 dot 5 dot 2 dot 6 dot 9 dot 10 dot 14 comma 18 comma 20, something like this. I have like created a list which is like populating some random numbers. Now what I want to do, I want to do a sorting on this. When I want to do a sorting on this collections dot sort, I would pass a list here. And now let me try to first print this list before and after traversal. Before sorting list and after sorting, let me try to print this. See, before sorting, whatever order you have maintained in the list, like 1, 5, 2, 6, 9, 10, 14, 18, 20, the list was printed as it is. But this collections is a utility class which helps you to sort the data structure. When you do a collections.sort, it would sort this particular list. It would basically sort your list. And after sorting, you see everything is in ascending order, right? Collections.sort. Whenever you do a collections.sort, you can basically go for a sorting, and this will sort everything in ascending order. Now let me try to do a reverse collection dot reverse and try to print out the list now. See, you are able to print out the collection in a reversed manner, like in the descending order. So this is like this collections utility class has a lot of methods which help you to basically, this will help you to basically perform a lot of shortcut operations like sorting. It can help you to sort the your collection in a ascending order or in a reverse order. It can basically shuffle as well. There are like shuffle methods as well. Let's say I pass list and I pass 2. Okay, let me do a collections dot shuffle and try to print out this list. See, it is basically printing out random order of the list. When you apply this collections dot shuffle, right, it would just print out the collection in a random order. See the last output, random order. This will basically give the elements in a random order. So 2018. Observe the output here. This will always change. So this is like random order of printing of the collection. So you can choose this collections utility class to perform a lot of things like sorting, shuffling, reverse, shuffling, and then there are like lot of other methods as well. You can choose to copy as well. You can copy from this source collection to any other collections as well. So similarly, if you try to create a set, right, let's try to create a set. Let's try to add set dot add one. Let's try to add some more entries in this set. Let's try to add 1 2 3 4 comma 5, and let's try to do a collections dot reverse set. Okay, okay, you cannot okay, we cannot directly do a reverse or sort on this set, but what we can do, we can convert this set to a list and then we can print this out. Let's try to print a set now. Okay, I think we cannot perform this with a set. We can perform this with a list. Okay, but these are some of the methods in the collections utility package. So this will basically help you to reverse, sort, shuffle, and then there are some more methods. You can choose to basically go over this documentation as well. So there are like you can create a queue out of this as well, like checked queue. You can, then there are like lot of different methods like copy. So you can copy from one list to other list, and you can do, means basically this is like destination. See this documentation, this is destination, and then this is source. Suppose you have created one list, populated some 5 objects into that particular list, and then you have some list which is empty, and that empty list you want to basically populate with your new list. So you can choose to use this copy. So let's try to do this. List of integers, integer list, and let's say it's a new array list, and let's do collections dot copy and this integer list is basically our destination, and this is our This list is basically our source. The first argument is the destination. The second argument is basically our source. So let's try to print out the list of integers, and I would basically try to print out this integer list. Let's try to print out this. Source does not fit in destination. Okay, let's say we pass some initial capacity. Mm, source I think we are getting some index out of bound exception here. Let me try to like, okay, I'll check this method and let you know about this later. But see, this collections is our utility class, and it has like lot of methods like sorting, shuffling, reversing your collection, and like copying. These are some of the functionalities that have like become very easy with this collections utility class. So this has made things a lot easier. Means you can like sort your data structure, you can like print it out in a reverse manner. So there sometimes you want in your real time application this type of functionalities. So yeah, you can use this collection utility package. So this was all about the collection framework. Like we have covered all the data structures which we thought of. Like we have covered lists, map, queue, dequeue, stack, sets, and some of the collection utility classes as well. If you have any doubts, let me know, or we can like conclude this call.